Okay, there we go. So anyway, those were the reminders. Make sure that we are working on things we need to catch up on if that's you. Otherwise, today we're talking about exterior angles. So yesterday we talked about interior, today we're talking exterior, and then also the properties of parallelograms. So we're going to start kind of talking about specific cases of different quadrilaterals because there's a lot of special quadrilaterals. There's parallelogram, rectangle, square, rhombus, trapezoid, kite, all those fun shapes that have four sides. We're going to talk about all those kind of the rest of this week. So today we're starting with parallelograms, since that's kind of one of the more general special quadrilaterals. So go ahead and grab whatever it is you're using to take notes, and let's get going. Oh, wrong page. There we go. Kind of, maybe. All right, so first, since yesterday we had a short class period, we did not get to exterior angles. Wasn't really anticipating that we would, but now we get to. So exterior, and actually exterior is a lot easier than interior. So this will be a quick little detour. So exterior angles of polygons and parallelogram properties. Okay. So first, exterior angles of polygons. The first thing we need to know about those is that the exterior angles of any polygon add to 360 degrees, which is what makes it so convenient because the interior angles for polygons add up to different things based on the number of sides. The exterior angles of any polygon always add to 360, so that's super convenient. And remember, kind of a refresher on what an exterior angle is. So exterior angles are if you were to kind of extend the sides. We've got exterior angles. Are all those ones on the outside. We talked about exterior angles for triangles. We didn't really ever show or talk about exterior angles for other shapes. So for other polygons. So that's generically what they're going to look like on other polygons. You can extend the sides on any other polygon. And then those angles formed are going to be your exterior angles. And they always add to 360. Okay. So, kind of the first way that we're going to apply this let's do something like this. All right. Then we're going to be told that this angle is 47 degrees. This one is X. This one is 75 degrees. And this one is also x. And we want to solve for x. Give everyone a moment to finish drawing. Okay. So we know the exterior angles of any polygon add to 360. So that should kind of be in our mind right away, is we're probably going to be adding to 360 here because we've got a whole bunch of exterior angles in this picture. So yeah, you could also kind of work with the interior angles, but on this one, it makes a little more sense to work with exteriors since we've got a lot of exteriors already, and it would take extra steps to work with interiors instead. So the first thing that I want to do real quick is notice that since this one is an interior angle, we do have to do a little step first to get this exterior angle right here before we can add to 360, because I can't add this one with them to 360 because this one's an interior angle. Okay, so real quick, looking at this, that this is a straight line here, how might I find this angle? What kind of adding or subtracting could I do? Anyone have an idea? Yeah, it's a linear pair. That's a good word, Caleb. Yes, this forms a linear pair, and linear pairs add to 180. So before I do that, I can just go 180 minus 47, which would give us 133. So I know this one is 133 degrees. Okay, so now we're ready to add up to 360. So now I can take all my exterior angles, and sometimes it helps if you're doing this on pen and paper to kind of circle the things that you're adding, because it can get a little bit messy. So I'm going to add this, 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 and this. And since it's a four-sided shape, there should be four exterior angles that you're adding together. So that's another kind of check you can do to make sure that you've got enough things added together, or that you don't have too many, is you can figure out how many sides there are, and then that's the number of things you should be adding together. Okay, so here we go. We've got 133 plus 75 plus x equals 360. Okay. So 133 plus 75 gives us 208, combining our like terms here. And then x plus x gives us 2x. And now we're just solving for x, so I want to subtract 208 from both sides. To get 152. And then we can divide by 2 on both sides, which gives us x equals 76 for our final answer there. Okay. So that's one type of exterior angle problem that we could see, where you add up all the exterior angles, you set it equal to 360, and it usually involves solving for x, or maybe even for just one missing angle. But anyway, that's one kind of problem. Any questions with that one? Any numbers we're not sure where they came from? Any steps we're not sure how they happened or why they happened? Okay. If you think of anything partway through, feel free to type it in the chat or unmute yourself and say so. But moving along, there's only one more thing about exterior angles that we need to talk about today, and it's exterior angles of regular polygons. So for regular polygons, Can anyone remember what makes something a regular polygon? Like, is this a regular polygon up here? Give us a hint. This one's not regular. So what is it that makes something a regular polygon? Equal sides, that's one of the characteristics. Good, Adon. What's the second thing? There were two. And it's on that same kind of a line of thought there. Equal angles as well, yes. So remember, regular polygon means they have all equal sides, all equal angles. So like a square would be a regular quadrilateral because it's got 4 angles that are the same and 4 sides that are the same. An equilateral triangle would be a regular triangle because it's got 3 equal sides and 3 equal angles. So for regular polygons, remember we had something special with the interior angles yesterday on a regular polygon. We also have something special with the exterior angles. So for regular polygons, the measure of one exterior angle is 360 divided by n, where n is the number of sides. So you just take the total, since all the interior angles will be the same on a regular polygon, all the exterior angles will also be the same on a regular polygon. So you just take the total measure of the exteriors and divide by the number of angles or the number of sides. So for example, one exterior angle of a regular 24gon. To do that, we would just take 360 and divide by 24. And we would grab our calculator and go 360 over 24, which gives us 15. And that would be our answer. That would be one exterior angle for a regular 24gon. Okay, so that's the other kind of questions you're going to see with regards to exterior angles. And that one's actually probably one of the more common questions that you'll see. So anyway, exterior angles for regular polygons. You just take the 360 and divide by the number of sides. Okay, so that's pretty much everything on exterior angles. So we're going to kind of move forward now into parallelograms and talking specifically about those. So before we do that, any questions, comments, concerns? Anything we want to go back to? Okay, then moving right along here to 7.2, parallelogram properties. A lot of the parallelogram properties might seem fairly familiar to you. And it's called a parallelogram, which is kind of nice and tells us a lot about it already. But here we go. Properties of parallelograms. So we're going to start our sentence with if a figure is a parallelogram, then there's going to be 4 properties we're going to look at here. 4, kind of 5, because one of the properties will have a little bit like addendum to it. But anyway, the first property: both pairs of opposite sides are parallel. That's why it's called a parallelogram. Everything, well, not everything, but a lot of things are parallel going on there. So both pairs of opposite sides are parallel. Okay, so what this looks like, kind of your generic parallelogram looks something like that, probably drawn a little bit better than mine, but it's freehand, with one pair of opposite parallel sides and another pair of opposite parallel sides. I'll try to do a little bit better drawing parallelograms for the next few. Okay, so that's one important thing about a parallelogram. And because of that, then we kind of remember back to our first or second quarter for depending on when you had geometry 1, we have to remember back to those parallel lines cut by a transversal and all that good stuff to give us some other properties and whatnot. So here we go. The second thing: both pairs of opposite angles are congruent. So what we're looking at there is then we have this pair of opposite angles here. Those are congruent. And we have this pair of opposite angles that are also congruent. Okay. And so kind of the addendum to this, knowing that both pairs of opposite sides are parallel and that both pairs of opposite angles are congruent, tells us, remembering kind of those consecutive interior angles when lines are cut by when parallel lines are cut by a transversal, consecutive interiors were supplementary. They added to 180. So that also holds here. Consecutive interior angles add to 180. So not only are these angles on the opposite corners congruent, if I take one from each, they add to 180. So that's kind of useful there. Okay, so there's 2 properties. We're looking at 2 more. Then we'll do some examples and be done. Okay, this one's going to be one that everybody likes because it's fairly simple to employ. And it is both pairs of opposite sides are congruent. So we have both pairs of opposite angles congruent and both pairs of opposite sides congruent as well. So this pair of sides is the same and this pair of sides is the same. Okay. The last one is the only one that sometimes people get a little bit confused about. And it is that the diagonals bisect each other. So if we remember things like angle bisector and perpendicular bisector and all that good stuff, saying that the diagonals bisect each other, remembering that the word bisect means that it cuts it into two equal pieces, cuts it in half. The diagonals cut each other in half. So picture-wise, if I draw the diagonals on here, corner to corner, they cut each other in half, meaning that these two pieces would be equal to each other because this line is cutting this one in half. And that also these two pieces would be equal to each other because this line is cutting the other diagonal in half as well. So that's what it means to say that the diagonals bisect each other. So there's our 4 properties. I'll give everyone a moment to finish writing them down. And then we'll move on to doing some examples of how we actually use these properties. Okay. So remembering our 4 properties, you probably want to keep this list nearby when you do your homework, when we're doing our examples right now. So we need both pairs of opposite sides parallel, both pairs of opposite angles congruent, and it's kind of addendum that the consecutive interior angles add to 180. Both pairs of opposite sides are congruent, and diagonals bisect each other. Those are all going to be important to us today. So here we go. Examples. What are we on for today? This is example 3. Okay. So we're going to have a parallelogram here. A, B, C, D. Just some notation real quick as well. When you see people refer to parallelograms, it's going to be with a little baby parallelogram in front of it, kind of like we did with triangles with a little baby triangle in front of it. And then it's just going to list the letters in order. Notice that I could not call this parallelogram A, C, D, B or something like that because the letters have to be in order of the way that they're placed around the parallelogram. You could call it DABC if you wanted to, or CBAD, but it has to be in order. You can't go from corner to corner when you're naming your parallelogram. So just another little side note. So we know that ABCD is a parallelogram. We also know that this side length is 3x plus 5. This one is 4x minus 5. And this one is 6x minus 10. And we want to solve for x and find the side lengths. Okay, so I'm going to solve for x and find the side lengths. First thing I need to do is figure out which two I can set equal to one another. Because they're sides, and we know that both pairs of opposite sides are congruent. So which two should I set equal? Any suggestions? Yeah, DC and BA. I like that. Because DC would be the one up here. BA would be the one down here. Those are opposite sides. Can't really do anything here because I don't know an expression for BC. So we'll go with these two. That should be enough. So we can go 3x plus 5 equals 6x minus 10. And then we're just solving for x. So I'm going to subtract 3x from both sides. We get 5 equals 3x minus 10. We add 10 to both sides to get 15 equals 3x. Divide by 3 on both sides to get 5 equals x. So that's part of our answer because we were asked to solve for x. And then we need to find the side length. So that means I need to go and plug it back in up here. And really, I only have to plug it into 2 of these things because opposite sides are congruent. So 6 times 5 minus 10 gives me 30 minus 10, which is 20. So that means that AB and CD, CD are 20. And then for this one, we can go 4 times 5 minus 5, which is 20 minus 5, which is 15. So that means AD is 15, and AB and CD are 20, and then CB would also be 15, since it's opposite of AD. Okay. Any questions with that one to start us off? Any numbers we're not sure where they came from? Anything we're not sure why we set it equal? Okay. Then let's do another. Let's go. We've got parallelogram EFGH. We know this angle is 2x plus 12, and this angle is 5x. And we want to solve for x. All right. Well, are these two angles opposite angles? Are they in opposite corners? Or are they consecutive? All right, together they will equal 180 degrees. Yeah, because that's the case where they're consecutive angles. Remember back to our second property, we had both pairs of opposite angles are congruent, but consecutives add to 180. So these would be consecutives, not opposite corners. So that means we need to add them and set it equal to 180. So 5x plus 2x plus 12 equals 180. Because they are consecutive, add to 180. All right, so then we get 7x plus 12 equals 180. Minus 12 on both sides, we get 7x equals 168. Dividing by 7 on both sides, 168 divided by 7 is 24. So that gives me x equals 24, and we're done there. Okay, so that's an example with consecutives. We got two more. All right, so we got example 5 and example 6. Okay, example 5, we have parallelogram ABCD again. And this angle is 87 degrees, and this angle is x plus 29 degrees. And we want to solve for x. All right. So what do we think we're doing with this one? Are we setting them equal or are we adding to 180? What do we think? Take a look at your properties of parallelograms. Are they opposite or are they consecutive? Are we going to add to 180 or are we going to set them equal? Well, it's different than this case, right? This is the case where we added to 180 because they were consecutive interior angles. They were next to each other in line, not in opposite corners. In this case, they are in opposite corners. So since they're in opposite corners, we're going to set them equal. So kind of our two different ones here, opposite corners, set them equal. Consecutive corners, add to 180. Okay, so setting these equal, we want to go 87 equals x plus 29, or x plus 29 equals 87, either way. Subtracting 29 from both sides, we get 58. Okay, so far we've dealt with opposite sides being congruent. We've dealt with consecutive angles adding to 180, and we've dealt with opposite angles being equal to one another. The last one, we're going to deal with the diagonals bisecting each other. That's going to be our last example for today. Or for now, anyway, until we get to our homework. There's always more, right? This time we're dealing with parallelogram HIJK. And this parallelogram has the diagonals drawn in. And this diagonal, or this part of the diagonal, is 2x plus 18. This one is x plus 40. And we are going to call this point in the middle O. And we want to find the length of OH. And HJ. All right. Well, we know the diagonals bisect one another. Remembering from this picture here, the diagonals bisect, so the parts of the diagonal are equal to each other. And generically speaking, when you're talking sides, a lot of the times you're just setting things equal because sides don't do things like add to 180 or anything like that. Segment lengths don't typically add to 180 or 360 or anything in that way like angles sometimes do. So a lot of times a safe bet when you're dealing with segments is to set things equal. And that is what we're going to do here. Sometimes you'll run into a case where they'll tell you like the full length and they'll give you a part of it and you'll need to like multiply one of them by 2 to get the whole thing. But in this case, we're just going to set them equal because I know that this part of the diagonal is equal to this part of the diagonal. So x plus 40 equals 2x plus 18. First thing I'm going to do is subtract x from both sides to get 40 equals x plus 18. Then we'll subtract 18 from both sides. So we get 22 equals x. So that's kind of the first part of our solution. We need to know what x is. But what we want is OH and HJ. So OH is just this half of the diagonal here. OH is x plus 40. So then that's just 22 plus 40, which is 62. Then HJ is the whole diagonal. What could I do to find HJ? Any ideas? There's a couple different things I could do. Yeah, you could add OH and OJ. You could like plug in X here and get OJ. What's OJ gonna be? Can we find it without plugging in X? I know these two are the same, right? OH and OJ. So we just found that OH is 62, right? So if this is 62, then this is also 62. So you can go 62 plus 62, or you can go 62 times 2. It doesn't really matter. But we should get 124 for HJ. Okay. So I know that was quite a few examples there. Kind of one example with each of our properties. Any that we want to go back to, any questions, any numbers we're not sure where they came from, any that we want to run through again? Okay, if not, then we are going to jump over to the homework and kind of take a look at that together. Today's homework is in big ideas. So for those of you who are tired of IXL, big ideas today, only 15 questions. And a lot of you are going, only, that's a lot of questions, but it's a mix of 7.1 and 7.2 stuff. So some of it's about polygon angles and some of it's about parallelograms. So here we go. Let's take a look at it together. Go ahead and open it up on your end if you can at the same time as a Google Meet. If you can't, then you can just follow along here. So looking at this first one, it says find the value of each variable in the parallelogram. So this is going to be kind of one of our you try type problems. So go ahead take a couple minutes, try solving for D and solving for Z using the properties of parallelograms. When you think you've got it, type "got it" in the chat, and we'll go over it together. If you started off with two equations, z minus 8 equals 20 and d minus 21 equals 105, you're on the right track, since we're setting the opposite angles equal and the opposite sides equal. A lot of setting things equal. So then to find z, you're just adding 8 to both sides to get z equals 28. And then for d, you're adding 21 to both sides to get d equals 126. Remember, on all of these big ideas ones, please use that checkbox to make sure that you've got the right answer in there. And if you don't, then try again. Remember, you get 4 tries that it'll check for you. And then beyond that, if you get like 3 tries and you're on your last one and you still aren't sure about it, ask for help. Either use one of these features down here, the question mark or that speech bubble, to get some help, or ask me. I'll be available after class today. I'll be available in office hours tomorrow, and during class tomorrow, we'll also go over any problems that you guys want to talk about. Okay, so let's go ahead and move along here.